Hi everyone, this video is on exercise 12 of question 3. So we have the curve y is equal to x squared plus 1, and then there is a tangent to this curve at the point 2,5. And also there is a normal to the curve at the point 1, 2, and we want to know what's the point of intersection of the normal and the tangent to the curve. So in order to find the point of intersection, remember that there is a fact that tells us if we have the equation of the two functions, then we can set them equal to each other to find the point of intersection. So in this case, we want a point of intersection of the tangent to the curve and the normal to the curve. So we need to find the equation of the tangent first, and then the equation of the normal second, and then we set them equal to each other to find the points of intersection. Okay, now in order to find the equation of the tangent, we first need to differentiate the equation of the curve. So divide by the x is equal to 2x. And remember that the tangent is at the point 2,5. So when x is equal to 2, we substitute 2 into the equation of the gradient. So divide by the x is equal to 2 times 2, and that is 4. So 4 is the gradient of the tangent line. So that's the gradient of the tangent. Now that we have the gradient of the tangent, we have the point that the tangent passes through. We can use the equation of a straight line, y minus y0 is equal to m times x minus x0. So remember that x0 and y0 are just the coordinates of the point. So now that we have this, we can just substitute them. So y0 is 5, the gradient is 4, and then x0 is 2. So y is equal to 4x minus 8 plus 5. And the equation of the tangent is equal to 4x minus 3. So this is the equation of the tangent. Right. Now we need to find the equation of the normal, then we can find the point of intersection. So remember that we already have the derivative, which is 2x. So we just need to substitute the x coordinate of the point that normal passes through. That's 1. So for the gradient of normal, we do divide by dx is equal to 2 times, remember the derivative is 2x and the x coordinate of the normal is 1. So we just substitute 1 into the equation and we get 2. So 2 is the gradient of, be careful, 2 is the gradient of the tangent at the point 1, 2, because remember, whenever you differentiate the function and then you substitute the point into the derivative equation, you get the gradient of the tangent at that point. So in order to get the gradient of the normal at that point, you need to find the negative reciprocal of the equation, of the gradient of the tangent. So that means the gradient of the normal is equal to so let's rewrite that, is equal to the negative reciprocal of 2, which is minus a half. So now we have the gradient of the normal. We also have a point on the normal, which is 1, 2. So we can now find the equation of the normal. Again, we use the equation y minus y0 is equal to m times x minus x0. So y0 is the y coordinate, which is 2, m is minus a half, and x0 is just 1. So y is equal to minus a half x plus a half, then plus 2. So y is equal to minus a half x plus 3 over 2. So this is the equation of the normal at the point 1, 2. Right. Now we want to find the basically the point of intersection. So we just need to set these two equations equal to each other. We want to find the point of intersection of the normal with tangent. So we say 4x minus 3, remember that comes from the equation of the tangent, is equal to minus a half x plus 3 over 2, which comes from the equation of the normal. I just made a calculation error here because a half plus 2 is actually 5 over 2. Yeah, sorry about that. Here is 5. So yeah, here is also 5. Okay, Now we just need to solve this equation. So I'm going to multiply everything by 2 to get rid of the fractions. 8x minus 6 is equal to minus x plus 5. And then this is equal to 9x is equal to 11. So x is equal to 11 over 9. So this is the x coordinate of the point of intersection. And we just substitute this into any of the equations. So we can substitute into the, let's say, on the equation of the tangents, because both of them have the same y coordinate. So it doesn't matter which one we substitute into. So it's going to be 4 times 11 over 9 minus 3, which is equal to 17 over 9. So therefore, the point of intersection is this, 11 over 9 and 17 over 9. So that's where the tangent and the normal meet. All right, that's it for this video, and thank you for watching.